Another thing we can do with these is just use them to simplify expressions. In this case, we have one angle that's a special angle, 30 degrees, and the other one was an unknown angle. We can use the sum identity for sine to write this out. We would have the sine of 30 degrees times the cosine of theta plus the cosine of 30 degrees times the sine of theta. We can substitute in the values that we know. For sine of 30 degrees, that's 1/2. And the cosine of 30 degrees is the square root of 3 over 2. Now there really isn't much that we can do to simplify this, but at least now if we knew our theta and we could find the values for these, then we'd have an easy way to get our answer. So the simplest that we could write this out would be 1/2 cosine theta plus the square root of 3 over 2 times sine theta. We can do the same thing here. We can use the difference identity for cosine. We would have cosine of pi times cosine of x plus sine of pi times sine of x. We can substitute in the values that we know. The cosine of pi is equal to -1. The sine of pi is equal to 0. So here we get negative cosine of x, and this term is going to go away because it's 0. So this whole thing turns out to be negative cosine of x. Another way that we can use these identities, if we have some information about the trig functions for two different angles, then we can find out the values of those trig functions for the sums or the differences of those angles. In this one, we know the sine of s, and we know the cosine of t, and we know the quadrants of both s and t. We're trying to find the cosine and the sine of the angle s plus t. And remember with these, we're trying to find exact values. So what we don't want to do is use our inverse sine or cosine functions and find the angle and then go back and use the calculator to find these values. That's not what we're trying to do here. So let's think about what we would need to find the cosine of s plus t and the sine of s plus t. If we write out our identities, the cosine of s plus t would be the cosine of s times the cosine of t minus the sine of s times the sine of t. And the sine of s plus t would be the sine of s times the cosine of t plus the cosine of s times the sine of t. What we want to know is whether we have all the values that we need to find both of these. So what we have is the sine of s, so we've got that one, and we've got the cosine of t, so we've got that one. What we don't know is the cosine of s or the sine of t. We need to find the cosine of s and the sine of t. That way we'll have all the values that we need to plug into those two. For both of these, we have the value of the other function. We're going to start by finding the cosine of s using our Pythagorean identity with s as our angle. So sine squared of s plus cosine of squared of s equals 1. And remember when we did this before, we rewrote these with the exponent on the outside just to make the substitution part a little bit easier to see. Now I'm going to substitute in the value that I know, which is sine of s is 3/5. I'm going to solve this for the cosine of s squared, and then I'm going to take the square root of each side. Simplifying over here, 3/5 squared is 9/25. Then I'm going to subtract the 9/25 from each side. That's going to give me cosine of s squared equals 1 minus 9/25, which would be 16/25. Now I want to take the square root of each side, and I have to think about whether this is going to be a positive or a negative value. So I'm going to go back and look at what quadrants I have. Both of my angles are in quadrant 2. In quadrant 2, cosine is negative. When I take the square root of each side, that means I'm going to use the negative value on this side. That's going to give me a negative 4/5 when I simplify it. So now I have the cosine of S is equal to negative 4/5. I'm going to do the same thing to find sine of t. I'm going to use my Pythagorean identity with t as my angle. I'm going to rewrite this with my exponents on the outside. Then I'm going to substitute in the value that I know, which is cosine of t equals negative 12/13. I can simplify this by squaring 12/13, and that gives me 144 over 169. Then I'm going to subtract that from both sides. 1 minus 144 over 169 is going to give me 25 over 169. Now I'm to the point where I want to take the square root of each side, so I have to check whether my answer should be positive or negative. In quadrant 2, the sine of my angle would be positive. I take the square root of both sides here. That means I'm taking the positive square root. The square root of 25 over 169 would give me 5/13. Now I have all four values that I need. I'm going to go back to my sum identities for cosine and sine. Cosine of S plus t is the cosine of S times the cosine of t minus the sine of S times the sine of t. And I'm going to plug in all four of those values. The cosine of S is negative 4/5. The cosine of t I was given is negative 12/13. The sine of S we were given is 3/5, and the sine of t we found is 5/13. Now it's just a matter of simplifying this. I'm going to multiply my fractions. This gives me 48 over 65. This one gives me 15 over 65. Since they have the same denominator, I can go ahead and subtract the numerators, and that gives me 33 over 65. That's my answer for the cosine of S plus t. For the sine of S plus t, my identity says that this is the sine of S times the cosine of t plus the cosine of S times the sine of t. Now I'm going to substitute in my values. The sine of S is 3/5. The cosine of t is negative 12/13. I was given both of those. The cosine of S we found is negative 4/5, and the sine of t we found is 5/13. If I multiply these, I get negative 36 over 65. These I get negative 20 over 65. If I add those two on the top, I get negative 56 over 65. That's my sine of S plus t. Now the last question was to find the quadrant of S plus t. I'm just looking at whether my cosine and sine are positive or negative. My cosine is positive. My sine is negative. I want to know which quadrant that would be, where cosine is positive and sine is negative would be quadrant 4.